All right, now I'm going to start playing around with my food aversions results and just run some basic means tests, maybe some correlations on these. And so when I'm thinking about the variable that's really most interesting to me, it's of all the various options, I'm really kind of interested in these responses of 4, that I will not eat this food under any circumstances, because I think that's really the most telling and will likely be related to whether or not someone endorses being a picky eater, or who knows, maybe even BMI. So what I'm going to just do is try to get a count of, for every person, how many times did they say, I will not eat this food under any circumstances? And so I can do this by transforming, counting values within cases. And I can go here, I'm going to create a new variable called aversions. It's just going to be a count of the number of times somebody said, I will not eat this food under any circumstances. And I'm actually just going to include all of my food items right now for the purposes of this. I could create different subscale calculations, like number of aversions within seafood, number of aversions within creamy cheeses, whatever. But I'm just going to do straight number of aversions out of the 60 or so foods, how many times somebody said, I will not touch this food. In define values, I'm just going to have it count the number of 4 responses of times that somebody said, I will not eat it under any circumstances. That was coded as 4. And I'm just going to calculate this. And this will create for me a new variable called aversions. And now I just have the exact number of counts. Look, somebody had 28 foods that they won't touch, no matter what. And then there's some people in here who are like 0. I'm fine with whatever. Okay, so that's interesting to me. Now I want to see if that relates to something. I wonder if it relates to the Marlowe crown. I doubt it. It shouldn't. I wonder if it relates to BMI. I wonder if it relates to gender. So I'm just going to run some tests. The first thing I'm going to do is just correlate aversions with Marlowe crown. Analyze, correlate, bivariate. Crown. While I'm here, I'll go ahead and see if it correlates with BMI. How about years of education too? We don't have age in this data set, but we do have years of education, which at least to some degree might be correlated with age, maybe. And okay, I'll just correlate those for now. And I see it is not correlated with the Marlowe crown at all, so that's great. That does give me an indication, or suggests discriminant validity. It's also not related to BMI, and it's not related to education. We see, however, that Marlowe crown is inversely related to education, which isn't that something? Okay, now I'm going to see if this aversions might be a function of gender, or if men and women answer this differently. So I'm going to just run means. Let's see, I could run it as a t-test, or I could run it as an ANOVA. I'll just keep it as a t-test for now. Independent samples t-test. My test variable will be aversions. My grouping variable will be, in my demographics, they are defined as 1 and 2. If I am unclear on that, I can just look at my variable information to make sure that it's 1 and 2 and 3. We don't have very many 3 in this data set, so I'm just going to look at men and women as the primary comparison. That's Spike. And here we see very highly significant differences. This is actually for equality of variance. The t value is 3.9, significant at less than 0.001, and this also generates our means for us, so that women were endorsing many more food aversions, but the standard deviation is also a lot higher. So that's that test. What else am I interested in looking at? Maybe whether or not picky eaters, self-proclaimed picky eaters, are different, and I would also guess that people who endorsed following a vegetarian or vegan diet would pop on many of these because of course they won't eat meats. But just to go ahead and confirm this validity, this time even though it's the same kind of test, I'll go ahead and run a one-way ANOVA on this. It'll give us the exact same results. So let's see, these are, do other people think you're a picky eater? Do you have any food allergies? You know what? Have you ever, I think this one is, have you ever falsely claimed to be allergic? I'm guessing that will show some differences. Do you follow a vegetarian or vegan diet? Oops, I did this the reverse way. Sorry about that. Vegetarian or vegan diet would be the factor here. The dependent list will be my aversions. And my options, I want to see descriptives. That'll actually give me my means. And there's how we run an ANOVA if you want to do it that way. Oh, well, we see that actually there are very few people who endorsed following a vegan diet. So let me go back to one of the other variables. Have you ever falsely said that you're allergic? Shockingly here, that people who said they're who lied and said they were allergic have a much higher mean than the others, and this is significant even though we have very imbalanced cell sizes, and ANOVA is actually quite robust to violations of assumptions. So there we are. For my next test, I'll just try, I'll do this one a little bit differently. I'll go back to the independent samples t-tests, and this time I'll do other people say you're picky? Yes and no, so I'll go ahead and code those here. Oops. Defining groups are coded as 1 and 2. That just lets SPSS know which levels to define. And here again a t-test, highly significant. Picky eaters endorsed many more food aversions than everyone else. And there we go.